15 integers A1, A2, A3, all the way to A15 are arranged in order on a number line. The integers are equally spaced and have property that the first term, the first number is between 1 and 10, the second number is between 13 and 20, and the last number, the 15th number, is between 241 and 250. What's the sum of the digits of the 14th term? The problem is here, the integers are equally spaced, and meaning that we have an arithmetic sequence. All right, let's use the general term in an arithmetic sequence, which is an is equal to the first term plus n minus 1 times the constant difference. And the constant difference is, we can get here, we have here the first and the second term range, a2 minus a1. The difference between any two consecutive terms is the constant difference, a2 minus a1. We can get upper bound, we can get lower bound. Upper bound is, if we have a1 is equal to 1, a2 is equal to 20, the constant difference is 20 minus 1, which is 19. Or the lower bound is a1 is equal to 10, a2 is equal to 13, then 13 minus 10, which is equal to 3. The constant difference is between 3 and 19. Now we have to relate this information to the 15th term. We have to fall into 241, between 241 and 250 for the last term. N is equal to 15, which is the 15th term. The first term plus 15 minus 1 times the constant difference. The 15th term is equal to the first term plus 14 times the constant difference. Now we need to decide the constant difference, and we have to get still 250, so it has to be something big. If it is 19, 14 times 19 is equal to 9 times 4 is 36. 9 times 1 is 9, plus 3 is 12, plus add, which is 6, 266, which is way more than the upper bound. Also, we are going to add the first term, keep in mind. So it can't be 19. If it is 18, it is 14 times 18. 14 times 18. And this product will be just 14 less than 256. If we subtract 14, we are having 2, 5, 252. And still way more than the upper bound of the last term. This is 252. If we do 14 times 17, this will be just 14 less than 252. 252 minus 14, which equals 8, 238. And which is less than the lower bound, but keep in mind that we are going to add the first term. And first term is between 1 and 10, so we can add at least 3, so we can get 241. So this should be our 213, this 238. The constant difference should be 17 and can't be 16. The argument is, what is 238? What is 14 times 16? And this one is equal to 6 times 4 is 24, which is 8. And 14, if we add 4, 12, 224. And this is constant difference times 14 is 224, and a1 is at most 10. If we add 10, we are getting 234, which is less than the lower bound here. Now, for sure, we know that the constant difference is 17. Now we have to figure out the first term. The constant difference is 17. 14 times 17 is 238. And to get this constant difference 17, which is a2 minus a1, a2 minus a1, a2 minus a1 is equal to 17. If the a2 is 20, a1 is then 3, which is 17. If a2 is 19, minus 2 is equal to 17. If a2 is 18, minus 1 is 17. So for a1, we have 3 options, 3, 2, 1. And here is it has to be 3, because 3 plus 238 is equal to 241, which is the lower bound of the 15th term. A1 cannot be 2 or cannot be 1 because it is at least should be 3 to get the lower bound of the 15th term. Now we know the first term, we know the constant difference, and we know actually the 15th term. The 15th term is equal to 241. We are looking for the 14th term. The 14th term is equal to the 15th term, 241, minus the constant difference, 17. Then the 14th term is equal to 11 minus 7 is 4, 3 minus 1 is 2, 224 is the 14th term. What is the sum of the digits of the 14th term? 2 plus 2 plus 4, that's 8, is the sum of the digits. Answer is option A for this problem.